Hello, today I'll show you how to convert your bicycle into an electric one that can reach 21.749 miles H with very little money. First, you need a hoverboard or electric skateboard, whichever term is used in your location. Choose the cheapest model, as it doesn't matter which one you pick. We'll take the necessary parts, a motor, battery, and controller, leaving one motor unused, which, for example, you can make an electric scooter, like I did in my previous video, which I actually did with this same hoverboard, with the motor that I had left over. And the thing about disassembling it, removing all the screws you see, the motor comes with some Allen screws that you take out, and it has like an aluminum block that comes out afterwards, and that's it. I mean, you have to remove everything you see. It doesn't matter if you cut some wires, you have to disassemble everything. You also have to remove the board. With a few screws removed, it stays as shown. I cut some wires, but it doesn't really matter if you do. We'll begin disassembling the engine. Remove the small screws from the back, then lift the cover up with some force. For instance, with the bicycle wheel I plan to use, which has 28 spokes, we need to make 14 holes on each side of each engine, so I used a pretty simple equation. For that, I used 13.5, which is the diameter of my engine times pi divided by 14, which are the holes I want on each side. Then I transferred that to a sticker. Let's say I marked 3 centimeters, which is what it gave me. I stuck that on the little cap that I had taken off the engine. I also stuck it on the other part, and then that marked it for me, where the holes were going to be, so I proceeded to make the holes. First, I made them with a little bit, and I also did it on the other side. That is, they have to be on both sides. And another thing I forgot to mention is that I removed the rubber. You can cut the rubber or directly pull it up. I removed it by hitting it. It's very easy, just hit it a little, and the rubber will come out. Also, with a larger bit, I made the holes a little bigger so that the rays fit in well later, you'll see. The next step is to extend the axle. This is the simple modification I mentioned, which I also did on the scooter. You just grab the rotor, which you already know comes out by pulling it up from where it's housed. You drill a hole with a bit. Well, I used a bit the same size as the screw I was going to put in, which in reality I cut the head off that screw. Then I ran a tap through it to thread it, and then I put the screw in. To ensure it stays in place, I added a few small welding spots. Not many, but just enough so that it can't come out in any way. Also in Protege, well, the edges have to make a hole in the cover of our engine, which is where it's going to come out. The axis, let's say. This is also more explained in the video I mentioned earlier. And then, well, I sanded it and gave it a coat of matte black paint to make it look good, a little nicer. It should be noted that by this point, I had already made the 28 holes needed for the bicycle spokes. But if you have a different type of wheel, remember that you have to make the corresponding spokes. If you have a 36 spoke wheel, create 36 objects. Then start disassembling the wheel where the motor will be mounted. First, fully deflate it. Then use a screwdriver to start removing the cover upwards. This, honestly, I had never done it before, but I found it quite easy. Once you remove it, you have to take out all the spokes. They have a little nut on the backside, so you have to loosen them. And once you loosen them enough, that comes out, and remove all the spokes as none can be left. We will reuse these spokes later with our motor. From the center, they simply go up without needing to unscrew anything. We will insert the spokes into the motor's small holes. If done correctly, they should fit perfectly. You have to bend them and make it tight. We will insert the spokes into the motor one by one, from the top through the center, ensuring they protrude equally on both sides. Then we are going to put one of the spokes through one of the holes. I use the one next to the little peak where the air is loaded. We will grab the next spoke and put it in the adjacent one, not the other one. That is, there has to be a hole difference between the two. Just like it is seen in the video, it's a hole with a spoke, a hole with nothing, and again, a hole with spokes. And so they keep inserting until they complete the whole round. And once they've inserted them all, they're going to grab the motor and turn it so that those spokes are tightened. For this, they're going to turn the motor. Once you have put all on both sides, are you going to insert the new spokes from the other side in case you haven't inserted them yet? And then it's easy. As shown in the video, turn the wrench one way while turning the engine the other way. They will stay on one side. They come in one direction, they all remain tense, and then the others are going to put them in the other direction. In the little hole that gets them more tense, I mean in the furthest they can put it. Once all the pieces have been inserted with a tweezer or the proper tool, which I lack, you will be adjusting each one evenly, one by one, so that the motor is well adjusted right in the center. And then all that's left is to reassemble the wheel. In the same way we took it out, we put everything back in and fit it on our bicycle. For this, you might have to make some modifications, but honestly, I didn't have to make any. Just a couple of taps, and on one side, put 2 nuts so that it tightens well and is firmly attached to the bicycle. Well, now what we're going to do is grab the plate again and connect the charging pin and the power pin, so to speak, to the plate. I put a lot of glue all over the parts that could move so that they don't break or come loose with the vibrations and all that. Now, there are 2 options. Either use a generic controller or use the hoverboard's controller. The good thing about the generic controller is that it's very easy to connect. It costs just $10. However, when buying from China, you must wait about a month for it to arrive in Argentina. So we're going to use the controller that already came with the hoverboard, which will serve us, but it's much harder to connect. It has limitations such as uncontrollable speed and limited functionality based on its design. In other words, we have to modify the operating system. For that, we were lucky that a group of Germans did something specifically for this. You won't understand it since you must download, compile, and modify the program. So I made my own compilation of my own program, which I've already compiled and assembled. So I'm just leaving you the file that you're going to need to upload to your hoverboard and unlock it. But of course, uploading it is another problem. Pay close attention to this. On these 4 pins that the board has, we're going to have to solder some pins to insert some little wires. Soldering wires directly works, but using pins is more convenient. Each pin has a specific function. They have unusual names, except the last one, the 3V, which you'll need to connect to the ST Link V2 tool. It costs very little money, and you can literally find it anywhere. Follow the names I gave you and connect each cable where it goes. Don't connect the 3V1. Then connect it to the PC via USB. Open the program from the description and drag the file mentioned earlier, also in the description, into it. And while holding down the power button on the hardware board with the battery in place, keep pressing the button, click on Target Program and verify, and accept everything that comes up. And if you did it right, the board will make this sound. The next step is to decide whether we are going to use a potentiometer as an accelerator or an electric bicycle accelerator. I had this electric bicycle accelerator, so I used it. But well, you also have to buy this abroad and wait for it to arrive. Connect the motor wires, matching colors and wire thickness, to the board just as it was previously connected. The thin wires go here where it is marked in the video, and the thick wires go to the 3 thick wires that are also marked in the video. For the accelerator, use the black and blue wires from here and the 3-volt wire from here. Carefully note which one it is, as you'll need to remove a small wire from there that connects to the accelerator. Connect it this way for the accelerator or this way for the potentiometer. So I've given you the full graph to help you find your way around as effectively as possible. That's it. I got a cheap little bag for about $5 to store everything. It fits right on my bike and you have to put everything inside. That's it. It's already complete. You can put some seals if you want, or tidy it up in some way, but the bike is already ready to ride. As I said before, I recommend buying the electric controller or doing it this way while also purchasing the controller. While waiting for it to arrive, you can use it with the original hoverboard plate, as explained in this video. Another thing I recommend is getting a larger battery or a replacement battery. because the included battery is very small and will only serve to travel about 10 kilometers. And regarding the performance of the bicycle, we did some tests, the first one without pedaling, just riding, and we reached a speed of about 25 kilometers per hour. We then tested using the electric motor and pedaling simultaneously. We reached about 32 kilometers per hour at that time, give or take a little. But the truth is that it was quite fast for what an electric bicycle is, especially for riding in the city. Regarding the torque or the power of the bicycle's motor, remember that the motors that really come for bicycles have a reduction inside which increases the torque. This one lacks it, so uphill it may become complex or progress more slowly. Well, you just need to give it a little help with your feet, that's all. Or simply use the engine that was left over as a spare engine or put it back on the other wheel. Thus, they would have double the torque, but use double the battery. And regarding the prices I end up leaving, the base version, let's say the cheapest one, around $74, and the upgraded version, let's say around $88. But what I recommend you buy to increase the autonomy and performance of your bicycle. Thanks for watching the video. I hope you do it and tell me how it went, and see you in the next video. I have another channel that I'll link in the description. Thanks, bye.